Now if I were to graph y is less than or equal to 4, that'd be a solid line. So this solid right here would be a line, of course. And that's here at 4. So I'd be up here, and then I click another point, and that'd be that line. Now, I'm going to do this just to illustrate, but our region shading tool, less than or equal to, is shaded down here. Okay, now this top one, y plus 2x is less than or equal to 0. If I were to graph that, y plus 2x is less than or equal to 0. Well, if I take 2x over, it becomes a negative 2x. And really, we're graphing y is equal to negative 2x. Now this is our slope. So m is negative 2, and I can put it over 1. And our number here would be our y-intercept, which there is none, so that's 0. So we come over here, and we want our line again, but it's a less than or equal to, so it's solid. So that's fine. It's going to pass through here, our y-intercept 0. And our slope is negative 2 over 1, so we're going to go down 2, right 1. Like that. Now, less than or equal to. Well, if I were to plug in a test case, like this point over here, 4, 0. If I put 4 in for x and 0 here, 0 plus 2 times 4 is 8. 8 is not less than or equal to 0, so that would not be shaded. It actually, if I plug it in a test case over here, like negative 5, 0. Put negative 5 here and 0 here. 0 minus 10 is less than or equal to 0. So this is still our shaded region. It satisfies both of those. Now 3x minus 7y is less than or equal to negative 14. This may be hard to do. 3x minus 7y is less than or equal to negative 14. Now, a very simple one is I could, if I think of it as 3x minus 7y is equal to negative 14, if I plug in x equals 0, 3 times 0 drops away, we got negative 7y is equal to negative 14. Divide both sides by negative 7, and you get y is equal to 2. Let me try negative 1. I think that works out nice. Actually, I don't want to do that one. I want to plug in y is equal to negative 1. So then I'll have 3x minus 7 times negative 1 equals negative 14. 3x plus 7 is equal to negative 14. Take the 7 over, it becomes a negative 7. And you get 3x equal negative 21, and you get x is equal to negative 7. So that point would be negative 7, negative 1. Okay, let's plot those. And this is still less than or equal to, so it's solid again. And we got, what do we got? 0, 2, right there. And we got negative 7, negative 1. Negative 7, negative 1. Okay, now the question is whether this area or this area should be our one that's shaded. It went ahead and did this area, but that doesn't mean that's our answer. So let's see. If we picked a test case up here, like negative 5, 2. Put negative 5 here and 2 here. That's negative 15 minus 14 is less than or equal to. Let me write it out. Okay, so negative 5, 2. This is x and this is y. So I got 3 times negative 5 minus 7 times negative 2. We're wondering if that's less than or equal to negative 14. That's negative 15 plus 14. We're wondering if that's less than negative 14. It's negative 1, which is not less than negative 14. Okay. So I want my shading to actually be down here. Wonder how I take the shading off of this. Well, I see a problem here. This right down here would be your answer. But I don't know how to do the shading. I just should have done it over on the side and then shaded it all at the end. I don't know how to undo the shading. Clear, I think, clears out the entire thing. Let's choose delete. Selected object. Okay, if I choose a selected object, hopefully that. Delete. Oh, okay. You have to click this right here. See how it turns green? And that, delete. And this one, delete. Okay, now the question is if one of these points down here works in every one of our inequalities. So, for example, if I choose -2, 0. If I plug in -2 and 0 here, I get 0 minus 4, which is less than or equal to 0. -2 here and 0 here, that's -6, is less than or equal to -14. No, it isn't. Okay, let me come back to here then. Choose a point up here. 0, 3. 0 there, 3 there, that's not less than or equal to 0. If I pick a point over here like 4, 0. That wouldn't work. How about a point over here? -6, 2. -6, 2, that works there. -6, 2, that works there. And it'll also work here. So this looks like our region. Let me choose this and delete this. Okay, one last check on this. Of course, this is assuming I graph these correctly. I don't usually do it by hand. I like using TI3, TI4. Okay, pick a point here. -6, 2. -6, 2, that would be less than or equal to 0. -6, 2, that would be less than or equal to -14. And it is, okay. All these are less than or equal to, so they're solid lines. And check our answer. And that's how you do that problem.